Hello everybody, welcome to this event. We will present you today how it's possible to create with AnalyticsCreator in 60 minutes a data warehouse from SAP Source. And also we will see how we get the data out with Power BI. Yeah, my name is Peter Smoli. I'm the CEO of AnalyticsCreator and one of the founders. Just to know for you, AnalyticsCreator is a Munich-based company. All of the development is based in Bavaria. And the product is now over 15 years on the market at the customer side. In a nutshell, AnalyticsCreator is a pure design time tool. This means that the only outcome is pure source code for using it in your environment. The key component of AnalyticsCreator is its comprehensive data modeling toolkit, as shown in number 4. And there are wizards with best practices and suggestions which help you to design your model more efficiently. You can choose data vault modeling, Kimball modeling, or the special mixed approach from us. Also, you're completely free to develop your own approach. AnalyticsCreator creates the whole data warehouse and also the processes to load the data from the source in the data warehouse and also in the cloud, in the cubes and whatever. AnalyticsCreator deploy an Azure environment and also a SQL server locally. We create SSAS packages, analysis services packages, and also Tabular model, Azure Data Factory, and also Synapse environment. We are able to deploy Power BI models and also Tabular models and Click models. Also, it's possible to create or export a data warehouse to any target database, for example, to a Snowflake, to an Amazon, or whatever. So. I must switch a little bit, sorry. Okay, this was the next page button. Just to speak a little bit about our customers. One of them is a very big famous company. They have built a data warehouse with AnalyticsCreator, and they have it done before without AnalyticsCreator, and they reported to us that they saved 80% time of costs to create the data warehouse for a special project in the IT controlling. Now, this project is really huge. There are 5,000 users online with Power BI on top. Our next customer, the name is MyMuesli. Some of you maybe will know the customer. It's in the food sector. They started really from beginners. They had not really idea about data warehousing. They just used cube models for analytics before. And they employed a new guy from the university directly, and he learned how to do data warehousing by himself, just with 4 days introducing AnalyticsCreator from our side. And they built the whole data warehouse from the sales, from the finance, from the purchasing, from every department by them alone. You find this success story also on our website. Yeah, next customer, we cannot name it here. This customer have a big SAP in their environment and have some SAP instances. and they reported to us that they are 20 times faster than estimated to create the ingest layer, just in this case. And we could not believe it. 20 times is really much. So we sandboxed this case and we recorded and we put this success story also on YouTube. You find it also on our website on YouTube. Yeah, this is something about our vision. It's really important to understand that AnalyticsCreator is a pure design time tool. This means there is really no component at the runtime on your environment, which brings really many benefits for you. Yeah, you can use the generated code free for everything. Yeah, it don't depend on how many entities you have or how many customers you have. If you're a software vendor and you want to deploy it to 100 of your customers, you can do that. And also, what makes it independent is the single holistic view for all users. If it's the business department or the developer, it's a single holistic view on the data model. And also, yeah, you can share it with everybody and use the data catalog for everybody. Yeah, what is very important also, focus 100% on the Microsoft Analytics stack. And I guess this is the reason, because we are really good in the Microsoft stack and you can do everything what you want. We have also an open repository. This means that the whole model which you design is stored in a database which is open for your use. So if you find something which is not in AnalyticsCreator, you can create and develop your own add-ons on this repository. You can store something in there, you can put it out, and yeah, you can do everything with it. We have, for example, customers, they build their own engine for creating a data warehouse in a PostgreSQL database, for example. Yeah. Maybe just one thing to announce. I just said before, we are focusing 100% on the Microsoft stack. In summer, we will announce, this is maybe a pre-announce, that we will be able to create also a data warehouse on SAP HANA, yeah, with the same model. So you have a single model and you can choose after that, I want to create a data warehouse on the Microsoft stack, so also on the cloud and also on premise, and also you can create a data warehouse on HANA. So we are just at the analysis at the moment and do some prototyping, and the prototypes were successful, and we think we cannot estimate at the moment when we are ready about that, but the real announcement will come in the summer. Okay, this is it from my side. Now Dimitri take over and we'll give you the demonstration.
Okay, then I will continue. Wait a moment, I will share my screen. Okay, I hope you can see my screen. Peter, can you confirm, please?
Yes.
Very good. Okay, and then let's start AnalyticsCreator and let's create the new data warehouse. New data warehouse project. Okay, let's call it SAP DWH, for example. Okay, new project, and according to you, data warehouse repository will be created right now. As Peter said, this is a database. In our case, it's located on my computer, and this database contains the full information about my data warehouse. Okay, now the empty repository was created, and first we will add the connector to our SAP Source system. I can even add, I can add the connector to the existing data source. We support different kind of data sources where we can read the data metadata from, like SQL Server, Oracle, ODBC, or drivers, text files, and so on. We can direct read the data from metadata from SAP. You can read the data from Azure Blob Storage, from OData interfaces. But in our case, at the moment, I have no access to the SAP system, and I will use the metadata connector. Metadata connector, this is information about the data source. Okay, this is a connector containing the metadata of my data source. It was stored in the cloud, and now we will use this meta connector to create my data warehouse. As I said, at the moment I have no connection to the SAP system, but I use this meta connector containing information about the tables related to SAP FI and controlling area. You can see there is a list of the well-known SAP tables, like booking headers, booking positions, accounts, customers, vendors, and so on. We created this meta connector, and now we can use this meta connector as a replacement of the SAP system. You can create your own meta connectors. You can use the meta connectors created by us. Okay, and let me start the data warehouse wizard. This wizard will help us to create the draft version of the data warehouse. Okay, I can see here the list of the tables and also objects in this meta connector. I will take some tables like booking headers, booking positions, okay, customers, vendors, accounts, company codes, document types, and document type texts. Okay, here I can decide what I will do with my table, with the tables. I will import them. I will historicize every table. I will create dimensions. I will create the fact transformation based on the booking position table. Okay, and there is something special with the table T003. This is a document types. I will add the information about the document types description from the table T003T to the T003. To do that, I will create the transformation between the import and historization, and I will add according attribute into this transformation. Okay, I think, okay, then on the next thing, we can decide about the names of the objects in our future data warehouse. For example, every dimension will have prefix team in the front, the facts will have prefix facts in the front, and so on. Here we can define some additional properties. For example, we will generate the calendar dimension for the specific time period. But let's just click on the finish, and I hope our data warehouse now will be generated. Okay, now AnalyticsCreator get the metadata stored in our metadata. In our meta connector, analyze the metadata and trying to create the draft version of the data warehouse. The same would be done in case we use instead of meta connector the true connector. Okay, and okay, here you can see this is a draft version of our data warehouse. This is a typical data layer diagram or data flow diagram. You can see here the different data warehouse layers from the left to the right. This is a source layer containing information about our data sources. staging layer, where we import the data into persistent staging layer containing historicized table. We historicize the data. Core layer, here we have the different transformations, and we transform the imported data, historicized data, into the facts and dimensions. And on the top of the data warehouse, we have our data mart layer containing facts and dimensions. This is our fact and our dimensions. Okay, let's take a closer look on the different elements in on this diagram. Okay, this is our data source. You can see, for example, this is the structure of the PF table, and the SAP contains all column descriptions and so on. Okay, then there is a coordinating import table in our data warehouse, imp backup F. And IP square, this is IP icon, this is the definition of our import package or import pipeline who would use Data Factory. And if I click on it, I can see here, for example, the definition of our import. There is a mapping between source and target columns. What I can additionally do here, I can define the filters, and I would do it. I will not import all the data from my SAP data warehouse, but for example, I will only get the data for the specific business year. And I can add the filter here. Year is equal to the variable year, and I can define this variable here. Okay, I will import. We have this is a demo SAP system. There have the data for the year 2013, and I will add the according filter. We will import the data for this specific year. Later, it is possible, of course, to configure this variable, to modify, to set the value of this variable prior to start the according import, and can do that. Okay, the same we will do with the table booking position by SE3, and we will add the according filter to this table too, to restrict the inputted data. Okay, then we have here two tables, T003 and T003T. The next is this T003T table contains the booking as a document type descriptions, and I will add this information to my T003 transformation. Okay, this is the transformation. This blue square, this is a transformation. The transformation in our case, this is usually view. We can take a look on this view. This is just the okay, we expose every column from this T003 table in this view, nothing specific. Here you can see the table participating in the transformation and the columns participating in the transformation. And I will here add the additional table. This is a T003T, the text table. And now we have to join the tables together. Our meta connector contains information about the references between the different tables, and I will here add this information. Is that the table number 2, this is the table number 2, is joined to the table number 1 using this reference. And I would get one additional column from the document text table. This is a description. Okay, let me call it text. And I will add one filter statement. I will only get the text in the English language. In this case, I would add here the filter statement is equal E. Well, now we added the one additional column to our document type transformation. let me synchronize my data warehouse. If I click on the synchronize button, the model which I created here will be materialized. And on my SQL server, the new data warehouse database will be generated, it will be created, and this database contains the structure of my data warehouse. And then we get some information from this created data warehouse, for example, the information about the dependencies. Okay, and now we can see this transformation contain the information. This transformation use these two tables, and then this transformation will be historicized. Okay, let's take a look on persistent staging layer. For example, okay, let's take a look on this CAN-A1 table. This is a customer table. The historized table contains the same columns like the source of the historization, plus 3 additional columns. 2 of them, this is these 2 columns. This is a valid from or valid to columns, fields, that font hist, that this hist in our case. This is the validity period of the specific data row. And we have here one additional column. This is a SATS ID column. This is the identity of the type big integer, and this is the surrogate key in this historized table. And this is the typical slow changing dimension historization. And the definition of the historization itself is, we can see here in this HP square and this HP icon. If I click on it, HP is historization package or historization pipeline, and here we can see the definition of the historization, and here we can configure our historization. Here we can see the list of the columns, and for every column in the table, we can define the historization type. For example, by default, slow SCD2 historization will be used. That means in case the specific field was changed, the history of the changes will be stored in the historized table. Sometimes we have less important columns, which history of the changes is uninteresting for us. In this case, we can use SCD1 historization. That means the changes in the column will be stored in the historization table, but no history of the changes will be stored. Or we can select none. In this case, the changes in the specific column will be not detected. That means if in case only this column, for example, will be changed, no history of the changes will be stored. Okay, we can decide what we will do in case the data in the source table are missing. For example, close means that the according data row in the historized table will be closed. That is hist or valid 2 will be set to the date of historization. You can select do not close, data remains valid in the historization table. There is one additional interesting option, add empty record. For example, in case data are missing in the source table, we can add it's called empty record to our historized table. And this empty record can contain the predefined values or the values which we get from the previous version of the data. We can define the filters to restrict the data which we will historicize. We can add the variables. We can add the calculated columns where we can, for example, calculate the differences between the new and the previous version of our data. Our historization can be configured very, very widely. And to perform historization, the storage procedures will be generated. For every historization, the own storage procedure will be generated. And here you can see the text of the generated storage procedure. And you can even modify the storage procedure. If I select here manually created, I can modify my storage procedure and add here some change and make here some changes. We can even historicize already historized data in case, for example, the source of historization contains the historical data. We can take this historization over into our into the data warehouse. It's possible too. Okay.
Dimitri,
yes,
sorry,
please.
Before you move on, just two quick questions. The first one is, can we get data from a DAX query?
Yes, it is possible. In this case, you should add the connector to your OLAP cube and use the DAX queries. As, for example, it is possible. Okay, yes, it is possible. This is possible, and some of our customers do that. It is possible not only import the data from the tables, it is possible to use the queries as a data source. You have add the connector to your OLAP cube and create the DAX query as the data source, and you can use it. That's possible. You said two questions.
Yes, the next question is, we use data compression and partitioning to improve our performance in our data warehouse.
Yes.
How does AnalyticsCreator do this?
Yes, of course. First, we can, for every table, select the compression type. You can select between the page or column store index compression. We have one, for example, option which we usually recommend to set. Compress. Okay, this is the default table compression type, and you can set, for example, here. Use column store index for compression, and okay, every table will become for every table the clustered column store index will be created, or you can select here row or page compression and so on. Okay, regarding partitioning, yes, you can define the partitioning. In our case, you can create the additional scripts which will be executed after the table is created, and in the script you can create you can create the according partitions, and of course we can create partitions in the generated OLAP cubes. You can do in AnalyticsCreator everything that you can do using SQL Server. This is okay. Okay, then I would continue our core layer. Core layer, you can see here these blue squares contains the transformations, and usually the usual transformation. This is a view, and here you can see the view generated by AnalyticsCreator. This is a regular transformation. Regular transformation means we define this transformation in tabular form, and view will be generated by AnalyticsCreator for us. You can create your own views. In this case, you will use a manual transformation type. In this case, you have to add the view text manually. We support different other transformation types. For example, script transformation, you can create the SQL Server scripts or storage procedures, and these scripts or storage procedures will be used to transform the data. But here we are using the usual view, and here there is nothing specific. We get the table and export every column from this table. What is interesting here, the predefined transformations. Let me remove all predefined transformations. If I remove them, I can see and take a look on the view. You can see every column will be exposed as is in this view. Okay, we have here not the technical name, but as business names. These are did it for us, but it's your own decision if you will use business names or technical names. Let me add one additional the predefined transformation, for example, trim. And let's take a look on the view generated. And you can see every varchar and then varchar column will be now transformed using rtrim and ltrim functions to remove the leading and trailing spaces. Okay, the predefined transformations will be applied based on the field type. And we created for you some predefined transformations, like, for example, trim to remove the leading and trailing spaces, for example, string null to an A to convert the null string into n.a. String. Let me do it, and let's take a look on the transformation. And you can see here rtrim ltrim to remove spaces, and then is null, and then n or n.a. based on the column length. The different words will be used. And we have some predefined transformations, for example, string max to 8,000, or I don't know, there is pretty many. Okay, and you can, of course, define your own transformations. Every predefined transformation is located here, and you can define your own predefined transformations. It is very useful to save time, if you will, for every column of specific data type, perform some transformations like removing spaces or convert type conversion and so on. For example, if you have the XML columns, you would convert every XML column column into the string in case you use, for example, Power BI, because Power BI and Tabular all cubes they cannot work with the XML type, or you will convert the binary values to the strings, and you can use it using this predefined transformations. Okay, let's take a look on this transformation, fact basic. This is our fact transformation. In this fact transformation, we combine the data from different tables. You can see here on the bottom, so the different tables. AnalyticsCreator found that the basic table has relationships with 5 other tables, and added these tables to this fact transformation. And here on the top, you can see we expose from every table the surrogate keys. That's ID. This is the surrogate key from the historized tables, and we expose this key. This is a typical factless fact transformation in our case now. Okay, what I will do now, for example, we have here as a table. Let me show you. This is the T003V. It is not bound to our basic transformation because there is no direct relationship between T003 and basic table. This table is related to the table BKPF, and Wizard didn't get this table into this transformation. We will do it manually. One moment. I will add here the new table. This is a T003 in the STG schema. Okay, and here I will connect my table number 7 with the table number 2. This is the BKPF, using the existing relationship. Okay, the relationships are available in this model. Except instead of the existing relationships, I can here add a reference statement, for example, usually in case of some ad hoc references. Okay, we added now this T003V table, and let's expose the surrogate key from this table. This table number 7, that's ID. Okay, and we will call this column FK with foreign key T003. Save. Okay. Okay, I would use this additional statement here. This statement can be used to avoid, to join the missing unknown members, the missing data to the unknown members in the according dimensions. You can see, for example, in case the data in the table is missing, the 0 as surrogate key will be used, and every dimension in our case has such unknown member having the surrogate key is equal 0, and in this case it will be used to join the unknown members. Okay, then in the table BKPF we have the column BUDAT. This is a booking date, and I will connect this BUDAT column to the calendar dimension. AnalyticsCreator created for us a calendar dimension. You can see it here. Calendar dimension, in our case, this is a manual transformation, and this is just the view provided us with the data with the calendar dimensions for every day starting from 1980 to 2040. The one row will be created, and we will join our track transformation to the calendar dimension using this BUDAT column from the BKPF table. And to do that, we should convert the information from this BUDAT column into the ID from calendar dimension. To do that, we can use the macro SAP date to ID from this. This is the alias of this column BUDAT. I can instead of this I can write the two. This is the alias. The two dot BUDAT, or this. This is the same, and I will call it FK BUDAT. Okay, what is a macro? Macro is very powerful, very simple, but very powerful possibility to create the small transformation bricks. And let me show you how the macros work. Let me take a look on the macro date to ID, edit macro. Macro, this is just a statement. In our case, this is the AnalyticsCreator statement, and some parts in this statement are replaced by the placeholder. This double.1, this is a placeholder, and when we call this macro date to ID, this double.1 will be replaced by the first macro parameter, first call parameter. We support different languages, Arcs and X, AnalyticsCreator and SSIS language, and this macro would convert the date, in case we should use a date, into ID from calendar dimension. It's very easy. In case date is less than 1980, the 1st January, the 0 will be returned. In case, okay, we check the boundary conditions here. Otherwise, we calculate the number of days between the 1st January 1980 and the date which we in the first parameter. But we cannot use this macro directly because the SAP date, this is a string, and for SAP date we have another macro. Let me take a look on this macro, subdate to ID. You can see first I convert this SAP date into the date time using format 112. This is format year, month, date. And then I call the date to ID macro. You can call macros and macros. This is, and let's take a look on our transformation, on our view. And you can see this macro call was replaced by the macro text. And you can see this double.1 was replaced by to BUDAT. This is our macro parameter. This macros, this is really, you can create your own macros and use them everywhere in AnalyticsCreator. And important is if you later will change something in the macro, you should only change the macro, and every transformation or every calculated column or every macro where the macro was used will be accordingly changed. Okay, now we have here every table which we will use in our effect transformation, and let's add some measures. In the table BSEC, we have, for example, this is the amount. Okay, let's call it amount. Okay, then we have the quantity, and let's add one more field. This is exactly, this is VAT, this is a tax, and save. Okay, we just added the three measures to three measures to our effect transformation. Very good. I think our effect transformation is completed. Okay, one small thing I will modify. This is our doc type transformation. You saw I added additional attribute, additional column to this doc type, and now I have to add this column to our doc type dimension. Okay, this column, this is L text. Exactly. Description, and okay, now we have our description in our dimension. Okay, what is interesting? Let's take a look back onto the fact transformation. This fact transformation, you understand, we work here, every table here participating in this transformation. This is a historized table, and it's pretty difficult to combine, to join the historized tables together. And how do we join the tables? Let's take a look on the view generated by AnalyticsCreator here on this from part, and you can see the first table here in this transformation. This is a snapshot table, CFG snapshot table. Snapshot table was created by AnalyticsCreator automatically, and this table contains dates. It contains at least one data row with the actual date, and this actual date is stored in the column snapshots date. And you can see every historized table is joined to the snapshot table using this join condition, snapshot date between date from hist and date piece hist, between date from and date to. Using this join condition, we get from every historized table the data which were actual for the specific snapshot date. That means this fact transformation will expose for us only the actual data in case there is only one data row with the actual date in the snapshot table. But we can add to the snapshot table more dates. For example, end of the last month, end of the March, end of the February, end of the January 2023, and so on. And in this case, our fact transformation will expose for us the historical data too, not only the actual data, but the historical data. And you can see the surrogate key from the snapshot table or ID from the snapshot table is a part of this fact transformation. And additionally, we have for the snapshot table, there is a snapshot dimension in our data mart layer. And this snapshot dimension can be used later in our follow-up cubes, for example, to take a look on the old versions of our data. In case you have only one snapshot, okay, you will see only the actual data in your follow-up cubes or in your reports. But in case you add more snapshots to this table, to the snapshot table, you will see more snapshots, and you will see you will be able to see the previous versions of your data. For example, you can select the snapshot month -1 or year -2, and you will see the old versions of your data. This is like additional timeline in your data warehouse, or you can provide your data warehouse with a timeline if you don't have the timeline at all. So we have some customers who use the snapshot historization as timeline, the real timeline. Okay, let me add one more thing. This transformation, fact by sec, is pretty complex transformation, and I will materialize the data on this transformation. To do that, I will add the persisting. I will materialize the data from this view in the table per sec there. Okay, and I will do it using persisting package pairs SAP, for example. Okay, let me synchronize my data warehouse. Okay, and now you can see the data from this view will be stored in this table during our ETL process. This persisting will be done using persisting package or persisting pipeline. If I take a look on it, the definition of this persisting, I can see here the persisting will be done using storage procedure. For every persisting procedure, the oven storage procedure will be generated, and we support different kind of materialization. Full means the content of the persisting table will be deleted and filled up every time completely. When we perform this persisting, we support different kind of merge materialization, historical incremental materialization. Okay, this is how the persisting work. Okay, and now here on the right side you can see our data mart layer. This is the interface layer of our data warehouse, and if I take a look on the table on the transformation in my core layer, for example, there is a small table stars, and here we can decide the specific transformation in the core layer in which data stars this transformation will be used, for example, as factors, as dimension. In this case, this dim BKPF in core layer will be used as dimension BKPF in our data star. This data star was created by DWH Wizard. You can create many stars, and okay. In this case, we have only one data star, and okay. What I will do additionally, you can see every table here has not only the technical name, like here, for example, BKPF, but a friendly name. These friendly names will be used later in our Power BI cube, which we will generate, and I will rename, for example, this fact transformation, the friendly name of the fact transformation, I will call it booking receive booking. Okay, and let me rename it to the booking 2. Okay, synchronize data warehouse. I should perform sometimes the synchronizations, because when we synchronize the data warehouse, the structure will be materialized, and we get from the generated data warehouse some information back into the model. And synchronization is very important because the syntax check will be performed during synchronization. If I make something wrong in the transformation, for example, let me add one column containing, I don't know, I will add here something what is wrong. If I take a look on the view which is generated, I can see, for example, there is something wrong, but I don't know that is wrong. Let me synchronize my data warehouse, and during synchronization, the syntax checking will be performed, and I can see there is an error message, invalid column in the transformation BKPF. Okay, and I can see the red border around this transformation. Okay, And now, okay, the same error message I would get if I click on the button create in DWH. Now I have to modify my transformation and delete, save, synchronize. And now I hope the synchronization will be successful without errors. Okay, and the only what I should do now, I will add some measures to my fact transformation. This is my fact transformation, and if I click on this, okay, if I click on it, I can see this object in the data warehouse. This is just the view in the schema star. This is schema star. This is interface layer or data mart layer of our data warehouse, and I will, if I click on this T-square, I can see the tabular definition of my view. And here I can see, for example, the all preferences created by AnalyticsCreator. I can see different friendly names. For example, I will add here some measures, and let me do that. I will take the column amount and use sum as the amount, quantity, and sum, or PAT, sum. Okay, I will take the customer and use distinct count of customers and vendors and distinct count of vendors. You can see here the measure name. You can, of course, use your own measure names, but AnalyticsCreator provides you with some the functionality. AnalyticsCreator can create the measure names for you. It's sometimes very useful because every measure name and the Power BI model should be unique, and we can automatically, for example, generate the measures based on the aggregation name, column name, table name. This is just the template. You can, of course, use your own templates. And in these templates, you can use these aliases like table name, column name, and so on. And the generated measure name you can see in the column parsed measure name. And here this is how the measure will be called. Okay, I think our model is ready. But you should understand, this is just the model. It's not the data warehouse itself. And now we have to deploy this model. To do that, we generate the deployment package. Deployment package, this is a Visual Studio solution. And this Visual Studio solution will contain everything that you need to deploy your data warehouse. And this Visual Studio solution can work without, you don't need AnalyticsCreator anymore in case after you created your Visual Studio solution. Okay, let's create the Visual Studio solution. Let's call it Azure. We will deploy our solution on Azure. Okay, we will create the DECPAC file. DECPAC files, this is the most modern way how to deploy the SQL Server databases. We will deploy this DECPAC file. Okay, if we will deploy it, I have to add here the name of the server as the database where the data warehouse should be deployed. Let me click on database. This is the address of our Azure server. Okay, the DB name, I would say AV. We have already one database on our server. I will use standard deployment, standard security. Okay. I will deploy it. Then I will generate integration service packages. I can generate Azure Data Factory pipelines too. In this case, I would use Azure Data Factory and Azure Data Factory pipelines, but especially in case SAP, Azure Data Factory has no suitable component to import the data from the SAP. Therefore, we continue to use integration service packages, and we generate integration service packages containing terabyte components to access the data from the SAP systems. And later you can deploy these packages on Azure Data Factory or launch these packages on premise. I will launch on premise, but I will fill up my Azure database using these integration service packages. Then I will generate the OLAP cube. To generate the OLAP cube and Power BI model. To generate the Power BI model, I will generate the XMLA script, and I will publish this XMLA script on our Power BI Premium XMLA endpoint. This is the address of my Power BI Premium XMLA endpoint. Okay. DB name Okay, I have to add here my username. Okay, username and password. Okay, and I will create cube during deployment. Cube compatibility type is Power BI. Okay, 2019 is the compatibility level for backpack and for generated SSS packages. Deploy SS configuration. Okay, I would say this is how the deployment package can be deployed to save our time, because it takes about 5 minutes to deploy everything. I already deployed the solution, and I will show you how the deployment package looks like and what happens after deployment. Okay, open project or solution. Here you can see how the deployment package looks like. Would be generate the deployment package right now. The deployment package, this is a Visual Studio solution or SQL Server Data Tools solution. First, we can see here the workflow package. The workflow package usually will be generated, and this workflow package contains, executes every other SSS package generated by AnalyticsCreator. Later, you only have to execute this workflow package to run your ETL process, and every other package will be executed in the correct order. Okay, let's take a look on the import package generated by AnalyticsCreator. Okay, you can see this is the import package. We import different SAP tables. There is one container per table, and this package is the usual package as if you would create this package by yourself. There is a logging task. We delete the data from the PKPF table. Then there is a data flow where we import the data from the SAP table into the according staging table. First, we are trying to import the data using bulk insert. In case something is wrong, we are trying to import the data row for row. Okay, nothing specific. Okay, and then update statistic and some logging information will be stored in the data warehouse. Historization package is very easy. Per historization table, per historized table, there is one procedure call, and this package will be used only to execute the stored procedures. We have another package to persist table. The persisting stored procedure will be executed here. There are some other files in this solution. For example, backpack file. You can deploy this backpack file manually using either SQL package.exe utility of Microsoft, or you can use SQL Server Management Studio to deploy the backpack files. There is an XMLA file containing the definition of our Power BI model. Some SQL files containing the content of SSS configuration table. this table will be used to configure the generated SSS packages. Okay, and now I can execute the workflow package, and my data warehouse will be filled with the data from the SAP system. Okay, and I already did it just to save the time. If I take a look on my Azure database, I have here this AV database, refresh. And this database contains the object which we created, defined in our model, some import tables, some staging tables, persistent staging tables. There are some views, and so on and so on. This is our data warehouse. And I already executed the workflow package, and I can take a look. We have the data already in this data warehouse. And now let's take a look on my Power BI cube generated. As I said, I already generated the OLAP cube. Power BI. Okay, you can see this is our workspace. This is a Power BI Premium workspace. Therefore, we can deploy directly to the Power BI using the Power BI XML endpoint. And this is a database generated, 1 hour by me. And this database, let me try to get quick insights, for example. And this is the OLAP cube was generated and was processed already. And you can see here some quick insights. Okay, have some data in the OLAP cube. Maybe I would show you the structure of the generated OLAP cube using Power BI Desktop. Please. Desktop. I will connect to this OLAP cube. Get data, Power BI dataset, demo SAP, and let's take a look on the structure. This is OLAP cube. Come on. Here you can see this is the structure of the generated OLAP cube, and this is the same structure which we have here in the data mart layer. We have one data star. This is this fact or booking underscore booking, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different dimensions. And this is what we can see here on this picture. This is a booking. We have here our measures, and we have different dimensions here. And if we will, we can create some reports maybe. So let me try to do something. Sum of amount, for example, and I don't know, dog types. Or where is the description? Yeah, for example. Or I don't know. Okay. Anyway, now we can start to create our reports. Our data warehouse is ready, and okay, I would say I'm done with my presentation. If you have questions, please, you can ask me. Okay, if there is no questions, I will give the board back to the Peter Smoley. Peter, would you tell something?
Yes, I'm here. Let me share my screen. Maybe the people have to think about it a little bit.
Okay.
I need to find the question. Okay, I share my. Just want to show one picture. Okay. Later. So, has anybody questions?
Okay, maybe I can show an existing productive project of one of our customers, just to that our that the user can see can see it, how it looks like. Okay, for example, okay, let me look on this one. Okay, you can still see my screen, yes, I hope.
Yeah.
Okay, well, this is the project of one of our customers. You can see this project is pretty big. There are mainly different SAP data sources used for this data warehouse. You can see this is a typical Kimball data warehouse. Okay, the different sources, staging layer, where the data will be imported, and persisted staging layer, where the data will be historicized. Then we have here the core layer, where the facts and dimensions will be created. And on the right side, we have a lot of different data stars. And seems to be pretty complex, but for example, let me select this one fact transformation, for example, fact delivery prod, set filter. I can set the filter on the specific object, and then I will see only the object related to this filtered object. And here you can see much better how the specific data star will be generated, will be created. We can see here the different SAP tables and staging layer, and so on and so on. And or I can select, for example, let me select the table here. On the left side, this is a sub perf table, set filter, and here I can see where the specific SAP table will be used. Or let me do it again with another table. Set, for example, this Power BI table will be used here in the following data warehouse objects. And okay, this is you can see here the data lineage capabilities of AnalyticsCreator. AnalyticsCreator can help you to work with very big data warehouses. We have the customers who have many thousands of the objects in the data warehouse, and without such lineage tool, it is very difficult to work with such big data warehouses. But AnalyticsCreator has many features which allow you to work with such data warehouses. For example, you can define the groups, for example, which will combine some objects and filter out some objects, and so on. And this is really very useful to use AnalyticsCreator in case you work with the big data warehouses. Okay, Peter.
Dimitri,
yes,
one second. We see in the chat one of our participants has their hands up. Ravi Kumar, if you could unmute yourself and ask a question.
Yeah, sure. Hi, Dimitri. I just want to know behind the scenes for the staging layer, persisted core layer. Actually, data is stored in Azure ADLS Gen 2. Can we see that data behind the scenes in Azure?
We can see the data, but first you should understand, AnalyticsCreator does not work with the data. We work only with the metadata. But the data you will see only after your all of or your database is processed, only after the data are imported. Okay, let me show you. There is one small feature which we can use to see the data directly in AnalyticsCreator. Let me take our demo project. It was this one, I think, sub demo. Okay. I can. Okay. In this is another project. One moment. I already connected my connector to the existing SAP system, and for example, there is a backup table, and it is possible in case this connector is connected to the SAP system. It's possible to preview the data. I can take a look on the data and in my SAP system. I just clicked on preview data, and I can see the data in this SAP table. I can add here the different filters, for example, and I can see the data. But as I said, AnalyticsCreator, it is not the ETL tool. AnalyticsCreator is just a data modeling tool, it's a developer tool. Because there is no data, for example, in the staging table in the model, because this is just the model. And but of course, I can go back to my Azure database, and I can see the data in the according table. But this database is unbound. We do not connect our model to the.
Sorry, I was originally thinking you're creating a blob storage objects behind the scenes for the persistent.
No, we create only the SQL Server databases. It is possible to create the blob storage objects too. AnalyticsCreator can, but if it is necessary, you can export the data from AnalyticsCreator into the blob storage. For example, we can take the persistent table and add export, and we can export the data into the blob storage. It is possible, but as I said, this model will be materialized as a SQL Server database. It is not Azure NoSQL or not Synapse NoSQL. This is pure SQL Server database.
Okay. Yeah, got it. And eventually you are linking it to Azure Analysis Services, right?
Of course, yeah.
Is there any way that you can publish to Azure Data Explorer or Synapse Analytics?
At the moment, where we can publish our Power BI model. Our multidimensional models can be published onto the multidimensional SSS, into the multidimensional OLAP cubes, Tabular OLAP cubes, Power BI models. We can publish into the Click and Tabular, and we can export the data into the different other. You can, for example, take your data mart layer and export the data from the data mart layer to the Synapse, to the Oracle, to the many other systems, because we have these export capabilities. I just only have to add the export, and every data will be exported into the according databases, for example, to the Synapse.
Okay. Thank you, Dimitri.
Welcome.
Thanks, Ravi. Dimitri, I think another question, I think referring to AnalyticsCreator is in the flow diagram, is there any way to add annotations or comments?
Sure. That is very important part of the AnalyticsCreator. You can add the different descriptions everywhere. For example, I can take, and this is what we usually recommend. For example, this is the SAP Connector, and you can add some descriptions, for example, to the columns, to the tables, and these descriptions will be inherited by every object in the data warehouse. You can see, for example, this meta connector, SAP FI, which we created, contains some descriptions. For example, every column has a description, for example. And this description was inherited by every data warehouse object. And this description will be the part, okay, you can see, I hope, this description here in the data mart layer. And this description later will be used when we generate the Power BI cube. This description will be stored in the Power BI cube. as the metadata, as a description for the according attributes. And moreover, when we generate our database, we store all descriptions as additional metadata in the okay, we store it. I can show you how it works. If I take the table, for example, CG BKPF and properties, every table, every column, sorry, not the properties, wrong, design. And if I take a look on different columns, for example, year, and I will see here the metadata, you can see the description fiscal year. This metadata will be stored not only in the model, but we store the metadata in the generated database. Therefore, okay, that's how it works. And we have, as I said, it is possible to create the friendly names, different descriptions, and you should do it only one time, only once, and all descriptions will be inherited by according objects. Okay.
Yeah, I think now we're at the end. If there are no questions anymore, then we come to the end. I have just 1-2 slides I want to share with you. Okay. Yeah. So this is this is about the data management survey 2023. We have won or was placed in the last 4 years on the first place in the data management survey on several products. You can see this here on the left chart that we're in the upper right position. This is the best, I would say. And we had 7 leading positions from 11. You can download this survey also from our webpage. So this is something I recommend to you, that you check out what is in there. There are a lot of customer testimonials in there, and also comments from the analysts. Yeah. So this is our contact address. Also, Aaron shared it in the chat, and yeah, feel free to contact us to get a call with Dimitri or me. Also, we have a limited promotion. You can ask us for an audit of your data warehouse architecture. This will be possible in the next 4 weeks. So if you are early enough, you can ask us for this. This is completely free. You can talk to our team and our experts, and we give you feedback and suggestions. What is the best idea to do with your data warehouse environment? Yeah. So I'm now at the end. Just one thing. Yes. Again, there is also a free trial version. The free trial version you can get from the web page, from the main page directly. There's a button, free trial. Press the button, fill out the form, and within 24 hours you get a free trial. You have a possibility to use really all features in there, and you have this for 30 days. Okay. Yeah, I would say thank you for joining us. I hope
you very much.
You had a useful case for this, and I hope you join us in the next of our events. We have in 3 weeks the next event. Every 3 weeks we have an event. In July and August we will have nothing, or just maybe one. Just check out our webpage. We will be happy when you join us. Thanks a lot. Bye bye.
Bye bye.